Hi students, welcome to JSR Maths Academy. Now we are going to discuss about polynomials of class 10. Let us observe the synopsis in this video. Actually, this polynomial topic comes under the algebra constants. A number having a fixed value, having a fixed numerical value is called as a constant. Just like examples 4, 7, 53, 20, 20 and so on. These are the numbers which are having a fixed value. So we call them as a constant. Now let us see about the definition of variable. Variable means what? Means a number which can take various numerical values is known as variable. A number which can take various numerical values is known as a variable. Examples x, y, z, a, b, c and etc. Here these variables are not having any fixed value. So depends upon our convenience, we can take different values for the one variable. That's why these are said as what? Variables. Now let us discuss about the algebraic expression. Algebraic expression is a combination of constants and variables connected by the four fundamental operations plus, minus, into and division signs is known as an algebraic expression. The combination of constants and variables by using these four fundamental operations. In the maths, we have four fundamental operations that are addition, subtraction, multiplication and division. So by using these four fundamental operations on variables and constants, we will get an algebraic expression. Let us observe the examples. 8x plus 7. This is a combination of constants and variable. Here 7 is a constant and 8x will be supposed to be as a variable. Why? Because x is a variable and multiple of x is 8x is a multiple of x. So 8x will consider as a variable. As we don't know the value of x, so 8x value also we don't know. So that 8x is a variable. So combination of variable and constant by using addition. So it is an algebraic expression. And if you observe the next example, 11x square minus 13x. This is a combination of variables. It is also known as an algebraic expression. Okay. Now this is another example for an algebraic expression. And here you should understand one important topic, that is of terms. Terms means what? The parts of the algebraic expression separated by plus or minus signs are called as terms of an expression. Okay, in algebraic expression there will be certain parts. That parts are separated by plus or minus. So by using them plus or minus, we separate the terms. That means before the plus one term, after the plus one term. If you take this example, 11x square minus 13x. Here in this expression it is having two terms. Why? Because these two terms are separated by minus. Before the minus, what we have, that is 11x square. This is a one term, and 13x, this is another term. So there are two terms in this example. And if you observe this example, 3x plus 4y minus 7 is having three terms, namely 3x, 4y and minus 7 are the three terms which is involved in this algebraic expression. That means we should understand that in algebraic expressions, terms are separated by plus or minus. Now let us observe the another important concept, that is of coefficient of the term. Coefficient of the term. Consider the term 8x square. In this term 8x square, in this case 8 is called as a numerical coefficient and x square is said to be the literal coefficient. In another example, if you take a 9xy, in this 9 is set with what? Numerical coefficient, and literal coefficient is xy. That means if you write a constant and a variable in the product form, let us take a constant as a 20 and variable is a y, and if you write them in the product form, then we can write as a 20y. This is an algebraic term. In this algebraic term, this 20 is set with what? Numerical value. This constant term will set with what? Numerical coefficient, and variable term, whatever variable is there, that is set with what? Literal coefficient. Okay. Now another important concept, that is of like terms. Most of the students, those who did not understand the like terms and unlike terms, they will be suffer to add the algebraic expression. So to know what terms can be added and what terms cannot be added, you should understand these two terms, that are like terms and unlike terms. Let us see the like terms. Terms having the same literal coefficients are called as like terms. The terms which are having same literal coefficients are said to like terms. Just like this, 8x square y and 5x square y and minus 7x square y. So these are the three terms. These are the three algebraic terms. These three terms are having same literal coefficient, that as x square y. That as x square y. So these are said to what? Like terms. And if you take 9x and 7xy, if you observe these two terms are not like terms. Why? Because first term is having x as a literal coefficient, and second term is having x into y as a literal coefficient. That means these two terms are not having same literal coefficient. So these are said to be as an unlike terms. Now you might have understand the definition of unlike terms. Terms having different literal coefficients are called as an unlike terms, as a 5x square minus 10x. If you observe these two terms are having different literal coefficient. First term is having x square as a literal coefficient, and second term is having x as a literal coefficient, and third term is having x cube as a literal coefficient. So these three terms are having different literal coefficients. So these are said to be as an unlike terms. You might have wondered that these three terms are having same literal, that means same variable x, so can we can say this as a like terms? Means no, we cannot say this as an like terms. Why? Because whenever we are going to consider about a literal coefficient, we must understand the powers of the variables also. Here, what is the power of variable? It is a 2, that means x square. Here power of variable is 1, and here power of variable is 3. These three terms are having different powers of a same variable. So these are said with what? Unlike terms. Though they are having same variables, these are said with what? Unlike terms. Let us say the next slide. That is of our topic, polynomial. Polynomial. Firstly, you should understand the polynomial definition, so that we can do the better in our chapter. Okay, an algebraic expression in which the variables involved have only non-negative integers as a powers is called as a polynomial. That means firstly you should understand that a polynomial is an algebraic expression. That means in algebraic expression, certain types of algebraic expressions are said to be as an polynomials. What type of algebraic expressions are said to be as polynomial? Means the algebraic expressions in which the variables involved having only non-negative integers as a powers. That means the algebraic expression whose powers of variables are non-negative integers, that algebraic expressions are said with what? A polynomial. If you observe this example, 2x square plus 3x to the power of minus 3 is there. This is an algebraic expression, no doubt in it. But we can we call it as a polynomial? Means we cannot call it as a polynomial. Why? Because as per the definition, an algebraic expression whose powers of variable should be non-negative integer. Non-negative integer means that is of positive integer. That is of positive integer should be as a power. So if you observe this term is having 2 positive 2 as a power, but the second term is having negative number as a power. So this expression is not a polynomial. To make it as a polynomial, this can be, if it can be written as like this, then it is said without polynomial. Now if you observe this, 2 to the power of x to the power of 5 by 2, 2x to the power of 5 by 2 plus 3x plus 7 is there. Can we call it a polynomial? Means no, this is also not a polynomial. Why? Because if you observe the power of the first term, variable of first term, that is of 5 by 2, which is not an integer. That means to say an algebraic expression as a polynomial, power should be an integer. And that should be positive one. That means nothing but power should be a natural number or whole number. Whole number in the sense 0 can be as a power. No problem. Okay. So I think you might have understand about the polynomial definition. An algebraic expression whose powers of a variable is a non-negative integer is said without polynomial. Let x be a variable and n be the positive integer, and a1, a2, and so a and b are the constant and real numbers. Then f of x is equal to an x to the power of n plus an minus 1 into x to the power of n minus 1 plus so a1 into x plus a0 is called as a polynomial in the variable x with a degree n. Here these are set without terms. That means an x to the power of n is one term, an minus 1 into x to the power of n minus 1 is another term. Likewise a1x and a0 are set without terms of the polynomial, and here an minus 1, an minus 2 are set without numerical coefficients. These are set without numerical coefficients. Okay, so this is a standard form of the polynomial with a degree n. That is of an x to the power of n plus an minus 1 into x to the power of n minus 1 plus 1. So a1x plus a0 is a standard form of the polynomial with a degree n. Let us see the next slide. That is of degree of the polynomial. This plays very important role in this polynomial chapter. Let us observe the definition of a polynomial. In case of a polynomial in one variable, the highest power of variable is called as a degree of the polynomial. What does it mean? It means that a polynomial can be having more than the one variables. So if a polynomial contains only one variable, then highest power of the variable is called the degree of that polynomial. If you observe this example, 5x to the power of 9 minus 3x to the power of 5 plus 19x to the power of 4 plus 6x plus 4 is a degree of this polynomial is 9. Why? Because it is a polynomial which contains only one variable, that is x. So highest power of this variable is a 9 here. So degree of this polynomial is 9. And in case of the polynomial in more than one variable, then sum of the powers of variables of each term is taken up, and the highest sum so obtained is called the degree of the variable. Okay, to understand this, let us see the first example. Okay, in the first example we have given with a 7x cube minus 5x squared and y square plus 3xy plus 6y plus 9. Okay, this is a polynomial in terms of x and y. That means x and y are variables. So that means this polynomial contains more than one variable. So to find out the degree of this polynomial, firstly you should understand that we should find out the sum of the powers of a variables of each terms. Here first term contains only one variable, so what is the power of this variable? That is 3. Second term contains 2 variables, so that 2 variables powers of them, sum of them is 4, and here third term is also contains 2 variables, and what is the sum of their powers is 1 plus 1, that is 2. Fourth term contains only one term and one variable, and power of it is 1, and last term is a constant, so degree 0. If you understand, if you observe this, in these sums, what is the highest sum? That is a 4. So degree of it is a 4. That means if a polynomial contains more than one variable, sum of the powers of variables in each term should be taken. That means firstly we have to find the sum of the powers of each variables of each term. In that sums, we have to take a highest one should be as a degree of this polynomial. In the same manner, if you observe second example, in the second example, degree of this is a 5. Degree of this is 5. Now let us say the next slide. In this slide we are going to discuss about types of a polynomial with respect to the degree. That means based on degree, types of the polynomial. First one, constant polynomial. Constant polynomial means what? A polynomial with a degree 0 is called a constant polynomial. That means every constant number is said without constant polynomial whose degree is 0. Let us take 7. 7 is a number, and here in this there is no variable in this. So if there is no variable, we can take 7 into 1. 7 into 1. That 1 I wrote it as a 7 into x power of 0, because we know that x power of 0 is 1. So that means every constant number can be written as a product of variable whose power is 0. So we can say that every constant is said with what? 0. Constant is said with what? Polynomial with a degree 0. That means a polynomial with a degree 0 is said with what? Constant polynomial. Example 7 and g of x is equal to minus 12 and so and so are said with what? Constant polynomials. Okay, and 0, second type of polynomial, that is 0 polynomial. 0 polynomials means what? The constant number 0, the constant number is 0 is said with what? 0 of the 0 polynomial. Only number 0 is said with what? 0 polynomial. The degree of 0 polynomial is not defined, because if you take f of x as a 1 polynomial is a 0, and second example, g of x is equal to 0 into x, and h of x is equal to 0 into x square, p of x is equal to 0 into x cube, and q of x is equal to 0 into x to the power of 12. What is the degree of this polynomial? That is 12. What is the degree of this polynomial? Is 3. And what is the degree of this polynomial? Is 2. What is the degree of this one? 1. What is the degree of this? Is 1. So if you observe this, these all are represents the same polynomial, same number as a 0. So a 0 can be written in these all ways. So in these all ways, the 0 is having in each term 0 is having different degree. So which one should be considered as the degree of this one? Means we cannot predict what is the degree of it. That's why we say that degree of the 0 polynomial is not defined. Degree of the 0 polynomial is not defined. Let us say the next type of the polynomial, that is a linear polynomial. Linear polynomial means what? A polynomial with a degree 1. A polynomial with a degree 1 is called the linear polynomial. Okay, in general, any linear polynomial in the variable x with real coefficients is of the form of ax plus b, where a and b are real numbers and a should not be equal to 0. That means what is the standard form of linear polynomial is ax plus b, where a is not equal to 0. And if you observe this first example, 11x minus 5, it is a linear polynomial. Why? Because degree of this is 1, and it is a linear polynomial in y. And third example, if you observe, in this example we have used two variables, that is x and y. That means x plus y plus 9. It is also said with what? A linear polynomial in x and y. Okay, but in our topic, in our chapter of polynomial of class 10, we are limited to the polynomials with only one variables. We won't come across such situations where we have used two variables in the polynomials chapter. Okay, but you should know that you should have a little awareness regarding this type of polynomials, so that I explain this in this example. Now let us see the next type of polynomial, that is a quadratic polynomial. A polynomial with a degree 2. A polynomial with a degree 2 is called a quadratic polynomial, and these are the examples of quadratic polynomial, and this is a standard form of the quadratic polynomial, that is of ax square plus bx plus c, where a is not equal to 0. Sir, what did happen if a is equal to 0? If a is equal to 0, then second degree term will be vanished. So we left with only two terms, that are bx plus c. So it becomes a linear. That's why a should not be equal to 0 in the quadratic polynomial. Okay, what is the standard form of quadratic polynomial? That is of ax plus ax square plus bx plus c. And what is the standard form of linear polynomial? That is of ax plus b. Now let us see the next type of a polynomial, that is of cubic polynomial. A cubic polynomial means a polynomial with a degree 3 is said without cubic polynomial. The standard form of this cubic polynomial is here ax cube plus bx square plus cx plus d, where a is not equal to 0. Here power should be this as a power. Okay, typing mistake is that, so this should be as a power. And next type of a polynomial is biquadratic polynomial. The polynomial with a degree 4 is said with what? Biquadratic polynomial. Okay, now let us see the types of polynomial with respect to number of terms. On basis of number of terms, we can classify the types in the classify the polynomials in the different types, that are, first type is a monomial. Monomial means what? Okay, monomial means an expression or else a polynomial which contains only one term is said without monomial. And binomial means what? An expression or else any polynomial which contains two terms in it, it is said to be as a binomial. And if it contains three terms in it, trinomial. These are the examples of monomial and examples of binomial. Here if you observe this example, in this example we have only two terms, that are 4xy minus 5x. These are two terms. Okay, before the minus one term, after the minus one term, so it is having two terms, so it is said with what? A binomial. And in this we have three terms, so it is said without trinomial. Now let us see the one more important concept regarding the polynomial. Whole topic depends upon this concept, that is 0 of the polynomial and geometric meaning of the 0 of the polynomial. 0 of the polynomial and geometric meaning of the 0 of the polynomial. Sir, here you should understand that 0 polynomial is different, 0 of the polynomial is different. 0 polynomial in the sense only number 0 is said to be 0 polynomial, and 0 of the polynomial means what? Let us see the definition of the 0 of the polynomial. A real number a is said to be as a 0 of the polynomial f of x if f of a is equal to 0. Sir, we did not understand that. Let us take an example. Let us take p of x is equal to x plus 3. Okay, if you take at x is equal to 1, what is the value of this p of x? That is p of 1, that is of 1 plus 3, that is of 4. Likewise, for what value of this x, this p of x becomes 0. For what value of x, that p of x becomes 0. Let us take another example. If x is equal to minus 3, if you take, then p of minus 3 is equal to minus 3 plus 3 is equal to 0. That means at x is equal to minus 3, value of p of x is 0. So minus 3 is said without 0 of the polynomial p of x. Likewise, here minus 3 is 0 of this our polynomial. And here finding of the 0 of the polynomial f of x means that solving the polynomial f of x is equal polynomial equation f of x is equal to 0. Suppose if you want to find out 0 of this polynomial, then to find out 0 of this polynomial, we have to take this as the equation, not in the type of polynomial. Then we have to solve for x, just like this. F of x plus 3 is equal to 0. Then on transporting this plus 3 to other hand, we will get a minus 3. So this minus 3 is 0 of the polynomial. Okay. And now we are going to see the geometrical meaning of the 0 of the polynomial. Geometrical meaning of the 0 of the polynomial. Here, before going to learn about geometrical meaning of 0 of the polynomial, you should know that geometrical representation of a linear polynomial and quadratic polynomial. If you take a linear polynomial, that linear polynomial is in the form of ax plus b. And if you draw the graph of for this, you will get a straight line. That means, what is a graphical representation of linear polynomial? That is a line. And in the same manner, if you take quadratic polynomial, the standard form of quadratic polynomial is ax square plus bx plus c. And if you draw the graph of it, it will be in the shape of a parabola. Excuse me. Parabola, don't be confused. Parabola means either it may be in like this or it may be in like this, just like a U shape. Okay. Now let us say the geometrical meaning of this 0 of the polynomial. Geometrically, zeros of the polynomial are x coordinate of the points where the graph of crosses or touches the x-axis. That means, if you take a linear polynomial and if you draw the graph of a linear polynomial and you got like this, suppose you got like this, this graph intersects the x-axis at 1, 0, then this x coordinate, that is 1 is said with what? 0 of this polynomial. And in the same manner, for the quadratic polynomial, if you take a graph of it, you make it like this, and this graph intersects the x-axis at 2 points, that is of plus 3, 0 and minus 2, 0. Let's suppose this point I'm supposing is a minus 2. Then this polynomial is having 2 zeros that are these x coordinates. What are these x coordinates? Plus 3 and minus 2. These two are said with 0 of this quadratic polynomial. That means what? What is the geometrical meaning of the 0 of the polynomial? Means the x coordinate of the point of intersection of the graph is said with what? 0 of the polynomial. And an nth degree polynomial can have at most n real zeros. Okay. And if you take a second degree polynomial, quadratic polynomial, a quadratic polynomial has at most 2 zeros. And if you take cubic polynomial, it has at most 3 zeros. At most 3 zeros means it does not have more than the 3 zeros. Okay. Sorry. Now let us see that another example. One more important concept: relation between the zeros of the polynomials. Okay, if you take a linear polynomial, for this linear polynomial ax plus b, 0 of this polynomial is minus b by a, that is of minus constant term by minus coefficient term. And if you take a quadratic polynomial ax square plus bx plus c, where a is not equal to 0, with alpha and beta are the zeros of this polynomial, then sum of the zeros is represented by alpha plus beta, that is equal to minus b by a, that is of minus coefficient of x by coefficient of x square, and product of zeros is alpha into beta, that is of c by a, that is of constant term by coefficient of x square term. And one more important property that we are going to discuss at the end of this section, that is of if two zeros alpha and beta are given to us, if alpha and beta are zeros of the quadratic polynomial f of x, then polynomial can be written very easily by using this formula, that is of k of x square minus alpha plus beta into x plus alpha into beta. That means if alpha, beta are zeros of the polynomial, then that polynomial is k of x square minus of alpha plus beta into x plus alpha into beta. And this can be written in the verbally as a f of x is equal to k of x square minus sum of the zeros into x plus product of the zeros. So these are the important concepts which are regarding to the polynomials, and I will be covering the exercise problems in the next video. Thank you friends for watching this video.